Hey folks, welcome to this episode on drawing covalent structures. In this particular episode, we are going to be looking at CO2 or carbon dioxide. First step is to figure out how many valence electrons each of these atoms are coming in with. We have carbon and we have oxygen. Now we have one carbon and two oxygens based on the formula. Carbon is in group number 4. It has 4 valence electrons. And oxygen is in group 6. It will have 6 valence electrons for a total of 16 electrons. Step number 2 is to figure out how many they would have if they all had full outer shells. So again, carbon, oxygen, we have one of these, 2 of these. And both carbon and oxygen need 8 valence electrons to have a full outer shell. So 8, 16, we would have 24 electrons. Now, to see how many they would share, we do our third calculation. 24 minus 16, that will give us 8. And they share electrons in bonds as pairs. So we're going to divide that by 2, and we're going to get 4 sticks. So once again, we will see that this might not make so much sense right away because we have carbon, which is most likely going to be our central atom, flanked by 2 oxygens. There's only 2 atoms that have to bond to the central atom, and that would only require 2 sticks. We have 4, meaning that we most likely will have a multiple bond somewhere, or multiple bonds. And then finally, we're going to see how many we have left. So we have 16 originally. We are using 8 to share, and that will leave us 8. They share in pairs, aka lone pairs. And so we will have 4 lone pairs. These are the numbers that we need. So again, if you don't know where these numbers are coming from, this is how many they have. And we use this number over here as well as over here. This is how many they would need, and we use that number over here. We also determine how many they're going to be sharing, and we use that number over here. Let's place these atoms. Now again, the atom that goes into the center is going to be the one that has the most unpaired electrons. Carbon is in group 4 and it has 4 unpaired electrons, while oxygen is in group number 6 and it has 6 unpaired electrons. 2 unpaired electrons. So carbon is going to be the one that is going to be the one in the center. So we're going to put carbon in the center. Treat the area around carbon as a 360-degree circle. And so if we look at the 2 atoms that we have, 360 divided by 2 oxygen atoms would give us 180 degrees. So that's where we're going to start our Lewis structure. We're going to put them 180 degrees away from one another. That means that if I put my oxygen on one side here, 180 degrees is going to be the opposite way over here. Without looking at how many sticks we have, we just need to bond this terminal atom of oxygen to the central atom and do the same thing to the other one. So we've now combined everything together as a single unit. However, we notice that we have 4 sticks. We've only used 2. We know that oxygen can make 2 bonds. It has 2 unpaired electrons. And we know that carbon can also make 4 bonds. So using this together, what we can say is that maybe this oxygen and carbon create a double bond, and the other oxygen and carbon will also create a double bond. So we can use a stick here, and we can use a stick there. Now, we'll only know if we did the right thing after we put in our lone pairs and start counting all the atoms that are, or the electrons that are being shared, and seeing if everything has a full outer shell. What we've said is that both carbon and oxygen both need 8 valence electrons to have a full outer shell. So let's place our lone pairs. We can first see that carbon has 2, 4, 6, 8 electrons around it. Each stick represents 2 electrons. So carbon is actually good. It has a full outer shell. We don't need to put anything around carbon. But let's look at the oxygen. Each of these sticks represent 2 shared electrons. So oxygen here only has 4 electrons. It needs 8. So let's put up 2 pairs of valence electrons. And now it would have 6 and 8. So that would mean that this is good. All right. Well, taking a hint from this, let's also put the other 2 pairs of electrons here. And we'd also get 2, 4, 6, 8. 2 in these bonds, 2 in these bonds, 6 and 8, and that is also good. So now every single atom has a full outer shell, which means that the structure is correct. Hopefully you found this helpful. Thanks for tuning in, and tune in for another example of more structures.